Okay, my friends, so let's get some solutions to this Jimmy Fallon Russian Egg Roulette follow-up quiz. What do we got here? These are Jimmy's games. So it took 3 eggs, 11% of the games, 4 eggs, 6% of the games, so forth and so on. Okay, very good, very good, very good. Hopefully you watched that video and it made sense. Okay, hopefully all this makes sense. What percent of the time did the first player lose? So all we got to do is add up the percentages from the odd numbered games, because those are the players. That's when the first player lost if it took an odd number of eggs. So that's the 11%, the 6, the 6, the 6, and the 6. Wow, that's a lot of sixes. 1, 2, 3, 4 sixes is 24, plus the 11 is 35% of the time, which would mean the other 65% of the time the second player would lose. Yeah, that's it. 35 here and 65 here. Now, I think, actually, now that I'm looking at these numbers, I bet you it doesn't come out to exactly 65, and here's why. It would be 6 plus 6 is 12, plus 39 is 51, plus 17 is 68, and then 68 plus the original 35 actually goes over 100%. And we'll come back to why that is in a second. That's not a... It's a mathematical error, but not a data collection error. We'll come back to that. So if you put 35 and 65, that's 100% correct. If you actually added the percentages, it'd be 35 and 68, which is 103 total percentage points. But there's a pretty simple reason as to why that happens, and we'll get to it in a second. Okay. It seems though at Jimmy's games it's better to go first, which is exactly the opposite of what we saw in class on the first day. We voted and we saw that it was better to go second. So now what I did was I built a simulator similar to the one that we played with in class this past week. And we're gonna look at question number 1, but use the simulator's results. So that's 2%, plus 9 is 11, plus 16 is 27, plus 16 more is 43, plus 9 more is 52% of the time. 52% of the time the first player loses, which would mean the other 48% of the time the second player loses. Let's just see if we got the same error here. 5 plus 12 is 17, plus 18 is 35, plus 14 is 49. So we do have kind of the same error, and it's the same exact thing going on that we'll explain in a second. So we got... Up here, we had a 35 to whatever we said it was, 35 to 68, or 35 to 65 if you just subtract it from 100. Here we have 52 to 49, or 52 to 48. Okay, and I said, that's interesting. That actually matches what we got in class. How could the data set from Jimmy be so different? Now, first of all, I want to address the rounding issue. Oh, I just told you the answer. It's a rounding issue, and it actually ties to the answer in number 4. Jimmy Fallon's, I don't know if anybody else noticed this, but when you look, there's a lot of 6% right here. A lot of 6%. And as it turns out, those aren't actually exactly 6%. Okay? And there's no way for you to know this. There's no way for you to know this, but I gave you kind of a hint on if you actually watch the available episodes of Jimmy Fallon. And part of this question, I actually gave you a hint. You might want to do a Google search of Jimmy Fallon Russian Egg Roulette. There aren't that many videos. There are only about maybe 16. I think that's what's in this data set, is maybe 15 or 16 videos. Which means these 6% are not like 6 out of 100. It's like 1 out of 15. So really, there's one episode here, one episode here, one here, one here, one here, one here, 3 here, maybe 6 or 7 here, and like 2 here. Very, very few data points. And as we're going to see over and over again in this class, when you have very, very few data points, it's very, very hard to get an exact idea of what's actually going on with a situation like this that we know nothing about. That's why the simulator, if it's set up correctly, gives you a much better idea. Like, for example, you can see that there was a spike up here at 8, just like there's a spike down here at 8. Yes, but on either side of that spike, the graph falls off, meaning as you get away from that mode of 8, the results get less likely. Well, that doesn't happen up here. You've got this spike, this island at 8, surrounded by a bunch of unlikely stuff except at 10. But again, that's simply because you had so few games, you didn't get a chance to watch the curve fill out like it did down here. So basically, the big idea here is sample size. We mentioned sample size in class this week. The smaller the sample, you can still do work with it. You can still get statistics from a small sample, but your error is going to be much, much greater. All right, hope that helped.